Guess what? Today is the last colloquium. Last colloquium. That doesn't mean that this is the end of the story, because next Thursday we have presentations by students showing their research mojo, such that it is. And then the following Thursday is awards and congratulations. In both cases, accompanied by free pizza, free soda pop.
The second one, there's also going to be a presentation from...
Oh yes, that's right. Since apparently nobody rehearsed those presentations, they need more time. Yes. We'll see that. Okay, anyway, it gives me great pleasure to introduce today's speaker, Kim Davies, who's here to tell us about the secrets of top-level domains, the inside story. Please pay close attention because he will give the speech in Australian. Let's welcome him.
So, firstly, thank you for the invitation to come. I'm very happy to come up here. I live in Los Angeles at the moment, and the ability to drive up and see Sonoma County for the first time, it's a lot of fun. So really what I'm here to talk about today is two things, described separately, but they're really one thing. Firstly is ICANN, and secondly is the Internet Assigned Numbers Authority, or IANA. What I do at IANA is I manage the domain name operations at IANA, and that includes what's called the DNS root zone. I'll get into what that is in a second. But first, just to introduce myself, I'm Australian. I studied computer science, and shortly after I finished up at university, some friends of mine were setting up an ISP back in Australia. It was 1994. The internet seemed interesting to me. It hadn't quite taken off commercially, but I joined up with them. You know, it was a pretty interesting time. It was really the definition of a startup working there. There was a few of us. We had racks of modems in a suburban garage. The funniest thing is when we finally got the money to move those modems into an office, we got it all wired up, we switched them on, and the wires kept catching fire because we had no idea what we were doing. We couldn't afford proper electricians. We were overloading the circuits. It was a real mess. But you know, today, that small company that I was involved with for 7 or 8 years is now the second largest ISP in Australia. It's listed on the stock exchange. It services millions of customers. So I was very happy to be working there at the beginning, and really working through that startup environment of having 4 or 5 staff, building up the company over several years really got me interested in a lot of things, and also gave me a lot of opportunities to work with the internet at the early stages. And to go through a long and tortured story, that's kind of how I ended up where I am today. One of the things I got to do while working there on the side was set up an internet exchange. An internet exchange is where different ISPs interconnect their networks. Again, we didn't have a lot of money, so what we did is we leased a storage room in one of the skyscrapers in the city. It was actually below the elevator shaft in the building, so we had to go down several flights of stairs. We put in all the interchange equipment in this little room, probably no bigger than this, and that's where ISPs all interconnected in the city. Last I heard that interconnect point still exists, of course. It actually transfers more internet traffic than any other exchange point in the Southern Hemisphere. So, you know, just little small things that seemed like out of necessity in 1995, you know, 15 years later have really taken off. One of the key things I did while working at that ISP is, at the time, the .au domain for Australia was run by an academic at University of Melbourne. In fact, it was very common for top-level domains of each country to be run by a single person. The .us domain was run by a single person. The .de domain for Germany was run by a single person. There was a person in Australia that ran the whole domain by themselves. But when the internet started really taking off in the mid-90s, it was really recognized in the community that we needed something better. We needed an organization that would run .au, it would set the policy, it would run it, you know, as a proper operation. So a small working group was formed. I was on that working group. I got to set up an organization. It now runs the .au domain. And you know, the .au domain now has over 1 million domains registered, and it continues to operate today. Now, when I was on the board of that organisation, one of the things I got to do was travel, representing Australia at internet conferences, representing .au. I first got an offer to work with European country code domains, so I worked in Europe for several years. And then finally, around 2005, ICANN approached me and asked if I wanted to be involved in the global management of the internet. So it seemed like a really good opportunity, and I took it, and I've been working at ICANN now for about 5 or 6 years. So just wanted to give a bit of background on who I am. I've come from sort of an ISP background in Australia, stepped into the domain name world, and I now work at ICANN, which I'm going to explain what that means. So, Jeff, I'll first talk about IANA. IANA is the Internet Assigned Numbers Authority. And what that is it's an entity responsible for managing the global Internet unique identifiers. Really, it's probably one of the first, if not the first, entity associated with the Internet. The Internet was invented in the 1970s, really 1969. The Internet as we know it today was developed in the early 80s. But you know, it was a research project for a few decades before it moved into commercialization. And the role of the IANA really started back in those early days. At first it was run by a man called John Postel, who's in the photograph on the right. Sitting next to him on the left is Vince Cerf, one of the inventors of the Internet. Vince Cerf, incidentally, was our chairman for most of our organization's existence. He only recently stood down. Now, for the first few decades, the IANA was really run under the radar. It wasn't noticed much by the community. It was basically performed in academia by John Postel. Most recently, he ran it at the University of Southern California. So he actually dished out every top-level domain. He dished out every IP address from USC. But you know, much like my experience I mentioned in Australia, around the mid-90s, there was this global recognition that having a guy in a university doing this, it needs to evolve into a more globally responsible position. So the US government actually took a bit of the initiative there. What they did is issued some, what was a white paper and a green paper. And in those papers they described private sector-led multi-stakeholder governance. Essentially what that means is we have companies that use the internet, private individuals, governments, all working together collaboratively, working out how we should govern these internet resources. And out of that, ICANN was founded. ICANN was really founded to be this institutional home where the IANA could be run. And ICANN was therefore created in 1998. We're still situated today in the same building in USC that John Postel ran the registry, and we continue to run those functions today. Now, one of the most common things, things you hear about how the internet is run is that it's completely decentralized, there's no central point of control. One of the most beneficial things of the internet is the fact that because there's no central point of control, it allows the internet to flourish, it can't be shut down, and so forth. In one sense, that's true. As a decentralized network, if you sever certain connections, it's not really going to harm the network. But on the other hand, what we're talking about here is a bunch of internet protocols. And internet protocols only work if they all point to the same thing, if they all work in the same way. So really what we're here to do is focus on those small technical parts of the internet where if they work the same, it allows the internet to interoperate. If they don't work the same, the internet stops working. And I'll step through a few examples just to give you a better sense of what I mean by that. So if you go to the Sonoma State website, you go to www.sonoma.edu. That in itself is a unique identifier. The fact that you can type that in here, you can type that in if you're living in Moscow, you can type that in anywhere and get to that website is the kind of global interoperability I'm talking about. Now inside that unique identifier is two two unique identifiers. Firstly, we have the HTTP at the start. That unique identifier in itself tells the web browser that this is a hypertext page or a web page. And secondly, we have the domain name. The domain name points to the particular server that contains the contents of that website. So those two unique identifiers themselves, firstly, they have to work the same all over the world, and they have to point to the same place. And by having that unique identifier, it ensures that you connect to the right place. But just two unique identifiers doesn't really tell the whole story. If we actually drill down a little, firstly, if we go one layer lower and look at a HTTP connection, HTTP is the protocol used to transfer web pages. Now, inside a HTTP transaction, firstly, it repeats the domain name. That's one unique identifier. Secondly, the web client tells the server what types of files it supports. The list of what those file types are is another registry that we maintain. So the fact that text/HTML means HTML web pages, that's something that we maintain in a registry. The web browser indicates what languages it prefers. The fact that EN-GB means British English is something, again, we maintain a registry that lists that, so the software implementers can all have the same indication as to what languages mean what. You might have been more familiar with 404 error codes when you go to a non-existent web page. Just those 3-digit error codes is another registry that we maintain. And so on and so on. So just within a HTTP transaction, again, we've just accessed one web page, and already we've got about 10 different unique identifiers that IANA maintains. We can keep drilling down. If we look at the TCP protocol, HTTP is transferred over a port number 80. The fact that 80 means HTTP is another protocol that we maintain, another registry that we maintain. And various different flags and options that are part of the TCP transmission are maintained by IANA. And I can keep going all day. If you go down one level lower to the Internet Protocol, the fact that the version number is version 4, that's an IANA registry. Various other flags are also part of IANA registries. And then finally, one of the more interesting registries maintain is an IP address. The IP address, I'm sure I don't need to tell you, is a unique identifier for every computer that's on the internet. We maintain the global IP address space, and that is issued by us, and I'll get into that in a bit more detail. So now we've gone down through the stack almost, and we find that just in accessing one web page, 15 or 20 different IANA registries have been invoked. And if any one of those numbers meant a different thing to a different software client, you effectively wouldn't have had an exchange of information. One thing that, if you're paying attention, you might not have noticed in the last page is there was no reference to sonoma.edu. There was just the IP address. So when a connection is made, all that's known at the IP stack is the IP address. So at some point, that domain name had to be converted into an IP address. And that's done by the DNS. DNS is a protocol for converting domain names into IP addresses, primarily. And so an exchange happened in the DNS as well. And again, what all these flags mean and so forth, that's indicated in IANA registries. And, I can keep going, but I'll skip. There's even lower levels of the network protocol that are involved here. So we saw port numbers, we saw domain names, we saw IP addresses, we saw flags, we saw headers, we saw all sorts of things. Fundamentally, we kind of divide everything we do into 3 sections. We divide it into domain names, number resources, and protocol assignments. Now, really what we do is all protocol assignments. There's internet protocols, and we have to make assignments of different numbers and naming systems. But, this part's easy. This part's complex. Domain names, there's a lot of money involved. They're hierarchical. There's a lot of different companies involved. That's a complex thing for us to manage. Number resources, and by number resources I mean IP addresses, that too is complex and involves a lot of politics as well, which I'll get to in a bit. But allocating things like port numbers, allocating flags that appear in headers that no one sees, no one's company relies on that working. No one gets to see it. The end user has no idea what that means. So we're able to just keep doing what we do. No money changes hands. We just do it. It's really uncontentious. So in conjunction with the IETF, which develops internet protocols, we kind of do 90% of our work under the radar and no one sees that we do it. It's really those top two things that get all the attention. So I'll talk a bit about IP addresses for a minute. One thing you might have heard is that we've run out of them. That's actually true. The conventional form of IP addressing, IPv4, what we do is we maintain the global space of IP addresses. And what we do is we hand out chunks of those to regional organizations who in turn hand those out within countries and so forth. We have no more left to give. We ran out of the last block of available IP address space about 2 months ago. In each region they have a small supply which will probably last a few more months, but the reality is within a few months there'll be no new IP addresses to hand out using IPv4. I mentioned we handed out in regions. There's 5 organizations that we handed out to. Aaron, RIPE NCC, and so forth. Aaron is the one responsible for North America, so if you're running a network and you need IP addresses for your network, Aaron is the organization to go to. Notably, APNIC is the first one to completely run out of their supply. So if you're in the Asia Pacific region right now and you need a new block of IP addresses, you're actually out of luck. You just can't get them. So the key problem here is that the IPv4 address space is just 32 bits. 32 bits is 4 billion addresses, far more than 4 billion people in the world right now. There's far more than 4 billion computers on the internet right now. It was just a matter of time. IPv6, on the other hand, the new version is 128 bits. Really, that should be a big supply for everyone. And just to show that this isn't a big surprise, I actually created this slide back in 2008 for a different presentation, showing the historical amount of available IPv4 space being the green line, and then projecting from 2008 when we expected to run out, and we expected to run out about March 2011, and that's pretty much exactly when it happened. The orange indicates how much free space is left in the regions. So again, we expect like within 2 or 3 months, regional IP address space will be exhausted. Just to emphasize just how much IPv6 space there is, only 1/8 of the entire address space is even devoted to what we call unicast, which is traditional use of IP addresses. And then of that 1/8, it's divided into 512 segments. Of those 512 segments, 1 has mixed usage, and then we've allocated just 1 to every region. So we've actually only allocated a fraction of a percent. Even then, we don't expect any of those organizations to come back to us for a very long time for another allocation. There's just so much of that address space that it really should satisfy the needs of the internet for the foreseeable future. So I'm going to move on to a topic that I'm sort of most involved with, which is domain names. My responsibility is managing domain name services at IANA. So this is kind of what I do on my day-to-day job. It's probably stating the obvious, but the DNS is a hierarchical tree system. Sonoma.edu is actually a child of .edu. .edu in turn is a child of what we call the DNS root. It's the DNS root that we operate. In effect, this is perhaps another term to use as a registrant, a domain registrant, and they've registered it from this entity. If you have a .com domain, you've registered it from the entity that runs .com. In turn, these entities that run these register their top-level domains from us. Now, I'm oversimplifying the politics of it a little, but fundamentally, that's how it works. So right now, there's 307 top-level domains. The vast majority of these are country codes. Country code top-level domains, there's at least one for every country in the world. So in the USA, you have .us. Canada has .ca. Of those that are not country code top-level domains, we have one called .arpa. That's used for internal network services. It's not really end-user visible. We have 21 of what we call GTLDs. The G stands for generic. But in fact, they're not really generic. There's only 4 that are truly unrestricted. You have .com, .net, .info, and .org. There's no restrictions on who can have them. They're available to anyone to register. Of the remaining GTLDs, we have 14 that are sponsored. And by sponsored, I mean they're for specific types of organizations. EDU is an example. EDU is limited to post-secondary institutions. So if you're not one of those kinds of organizations, you can't obtain one. And then we have 3 that are sort of in a special bucket where there's some restrictions, but they're mostly open, so we categorize them differently. And then finally, we have some testing domains that we use for testing internationalized domain names, which I'll get to in a second. Now, of those 21, this is the list of what's out there today. We have, some you've probably heard of, and maybe some that you haven't heard of. One of the reasons ICANN exists right now, not just to manage the IANA, was the fact that if we go back in time 15 years, and if you wanted to register a .com domain, there was one company you could go to. It was called Network Solutions. You charged something like $130 a year for a domain name, and you had no choice. If you wanted a .net domain, you went to Network Solutions. If you wanted a .org domain, you went to Network Solutions. So, they were a monopoly, and another one of the reasons ICANN was created was to break up that monopoly. So what ICANN did shortly after it was created was create something called registrars. It broke up the market for domain names and said that rather than the registries selling directly to customers, registries could only be wholesalers. They had to then sell domains to these new entities called registrars. They had to sell them at a much lower price, and in fact, the wholesale price now is something of the magnitude of $3 or $4 a domain. And then those registrars could compete with each other on price and service. So today there's I think over 1,000 registrars you can go to. You might have heard of a company called GoDaddy. They're the largest of the registrars. But those kinds of companies simply didn't exist 15 years ago. It's an opportunity ICANN created to allow competition between domain registration. So you can get a .org, a .net, a .whatever, and go to different companies and choose your price, choose your level of service. That's something new that ICANN has brought in. And in fact, as an organization, we have about 120 staff, and I'd say the majority of those staff are purely devoted to things like registrar compliance, accreditation, managing that side of the business, less to do with the IANA side of the business. So, one of the interesting things about ICANN, I mentioned in the beginning that we're multi-stakeholder, we have governments involved, we have non-profits, we have the companies that sell these domains involved. We create the rules that are associated with how domain names and so forth are issued. And we rely on those communities to help us out. And as a result, it really gives me a headache, but ICANN is an extremely complex organization. We have committees, we have supporting organizations, we have groups, we have task forces, there are so many different ways that ICANN is constituted that we have representation from all these different organizations. And I'm not going to go into the details, I can certainly give you pointers later, but at the end of the day we have governments, we have engineers, we have everyone involved. And ultimately, when you see a decision coming out of ICANN to create a new top-level domain, to treat IP addresses in a different way, to change the rules in some way, it's sort of come up through this consensus-building process where all these different groups participate in setting the policy. So the most controversial thing we've done lately is introduce a new top-level domain called .xxx for adult entertainment. We have 3 meetings every year, 3 sort of summits, so to speak, and at our last one, our board approved .XXX. And it wasn't after a short amount of consideration. It actually took about 7 years for that to be approved. But, you know, just an example of some of the work that ICANN does, you know, really you know, has an impact and makes news. But some of the other stuff we do doesn't get reported much in America, but really makes the news everywhere else. And one of the things ICANN should be most proud of, I think, is our work in internationalizing the domain name system. Until recently, all domain names had to be in Latin characters, and by Latin characters I mean letters A through Z, you know, ASCII characters. But if you're, you know, if you spoke Arabic, if you spoke Chinese, and you write using those script systems, you know, using ASCII characters is tough. If you're not used to that, accessing internet identifiers can be a problem. I mean, just imagine, for most of you, if you had to write web addresses in Japanese or some other language that you're not used to, that would be a significant burden to using the internet. Starting last year, it's now possible for countries to have domain names in their own scripts. So in this case, it's the .Egypt domain or .Masr. That is completely written in Arabic. And one of the interesting things about this is it's actually written right to left. So the top level domain is here, the second level domain is here, and you read it, you know, this way. So that's another project that's taken a number of years within ICANN, and we launched last year, and there's been massive adoption of that. China has its .China domain, you know, Russia has .RF for Russian Federation, and these are being used a lot. One of the interesting things that I'm personally, you know, responsible for, and my team at ICANN, is assigning those country code top-level domains. What we do is we find, well, we don't find, we receive proposals on how to run these country code domains. Generally, there's an organization that's kind of like ICANN in each country, sort of a non-profit, something similar, that runs these domains within those countries. They set the rules, they set the prices, and it's up to those local internet communities to decide how they run. Some countries, you know, most countries run it purely for their own citizens. They run it, you know, for their own availability. But, you know, in other countries, and you might have heard of .tv, .co, in those cases, those countries have decided, let's commercialize this. Let's sell our domain names all over the world. You know, make them available to everyone, and that's completely within their right. So we really leave it for the countries to decide how their country code domains are operated. One of the more interesting things we get, also in conjunction with that, is we have different entities coming up to us asking for country code domains, and in effect asking for their countries to be recognized. Country recognition is something that, you know, is a political challenge. It really calls for sort of delicate diplomacy. Here's an extreme example. This is an abandoned offshore military fort in the English Channel called Sealand. They claim that they're a country. They're outside of the international maritime border of England. I think something in the 1970s. A guy decided to, you know, invade it, set up his home on there, and declare himself a country. And so, you know, you have a lot of entities where they, you know, claim recognition, and you know, perhaps they're not very well internationally recognized. And we're called upon when we're asked to assign them a country code, and you know, we're left with a question: what do we do? And you know, this is a bit of a silly example, but some of the more real examples is you have places like Kosovo, Somaliland, South Sudan. They've had perhaps referendums for independence. The question is, when do they become countries or not? We actually punt that question. We actually rely on the United Nations to tell us. It doesn't stop countries asking us, but you know, thankfully the United Nations, one of their areas of expertise is country recognition. So we rely on the United Nations to tell us what is a country and what is not a country. In fact, we even have some of the sort of Indian nations within the US apply to us, claiming their own sovereign countries as well. I'm going to sort of fly through this a bit because I notice I'm running a bit low on time. But one of the key things about country code domains is that we explicitly don't give them purely for governments to operate. They're actually designated for local internet communities. And what we mean by that is that it's really internet users that benefit from these, not governments. And we're pretty explicit about when we receive applications about who should run a country code domain and how they should be run in the interest of the local internet community, not just the government. Sometimes that can be a little tricky because governments might have a very different view to how the domain is run to their local internet users. In those cases, we try and let them build consensus within their country and argue it out internally. Only once they come to a decision about how to run their domain should they come to us and have us allocate and assign a country code. Now, I've talked a lot about country codes, but the biggest piece of work ICANN has ever worked on right now is called new GTLDs. And it's something that is a very active piece of work. And effectively what that means is we're going to really open up the rules. I mentioned there's 307 top-level domains, 21 of which are these generic top-level domains. But it's anticipated that the rules will become significantly more open so that there can be almost anything. There'll be specific rules on how you can apply, certain rules for trademarks, certain rules for building community consensus and so forth. Like if you're, for example, you're applying for .Berlin and you're representing Berlin, how do you maintain that you were from Berlin, that kind of thing. But fundamentally, this will change the landscape of how top-level domains are assigned. So, I've just put a really small selection, but there's literally hundreds of companies that are in existence right now that are waiting for us to finalize our rules. And once they're finalized, they intend to apply for all these top-level domains. So, in the next 1 to 2 years, I think you'll probably see a lot of these existing. And it's really an area of a lot of active work within ICANN. In fact, it's so active that we were called before Congress yesterday to testify about why we're doing this. It's very public, this new TLD process, and there's a lot of interest involved. In this particular case, the Intellectual Property Subcommittee, I think that's what it's called, was very interested in what the implications are for companies that have intellectual property. One of the complaints we hear is that these big companies that have a lot of trademarks, right now they feel obligated to register all their trademarks as domains in all these different top-level domains. If suddenly you have hundreds more, they believe they'll have to register them in all these new domains, which amplifies their costs. So there's a lot of hesitancy from big companies that we launch this initiative because they fear that their costs will increase and the cost of compliance will increase. Facebook, if someone registers a domain name very similar to Facebook, Facebook will probably sue them or try to get the domain back to stop it being confusingly used. And if there's a lot more domains, that job will be a lot tougher. But that's not a universal opinion. There's actually companies like Canon, the camera company. They've stated publicly they're going to get .Canon. They want to apply for .Canon and use it for all their products. So, different companies have different opinions, but what's for sure is that there's a lot of interest in what we're doing in this space, and I think we'll see a lot of changes to internet addresses in the next few years. I think one of the most interesting things about ICANN for me personally is the fact that it's a space where politics are played out on a small scale. It's really a microcosm of world politics. You have governments there, you have private sector, you have a whole bunch of people. And at the end of the day, they're debating about things like IP addresses and domain names, which in the grand scheme of the world perhaps don't mean a lot. But you see a lot of ancient rivalries, politics, philosophical differences played out in ICANN because it's an interesting space you know, on the cutting edge of technology, so to speak, where governments and so forth get to state their opinions. Most interestingly, about 5 years ago, the United Nations convened a summit called the World Summit for Information Society. I think that's right. And one of the key themes there is, should the private sector be involved in managing IP addresses and domain names? Shouldn't governments take control over all of this? Now, bear in mind, ICANN was created to be this multi-stakeholder organization precisely because most people believe the internet is so popular today because it wasn't controlled. You know, there was a lot of regulation on things like telephone lines, a lot of regulation on other things, but the internet flourished without control. So ICANN was created to sort of loosely steer things but not get too involved in controlling how you use the internet. But some governments believe that, you know, governments now should have a stronger role, should control how IP addresses are used. Governments should control how domain names are used rather than letting the community decide together. So as a result of this summit, they have meetings every year called the Internet Governance Forum, where world governments meet together, and they talk about, you know, how ICANN does its job, whether domain names should be moved into governments or whether the management model should change. And you know, it keeps us on our toes, but we know that we can't take for granted the fact that private sector coordination is assured, and that there's certainly some governments that would like to take it over, and there's some entities that would like to fundamentally change how we manage our protocol assignments. So I've kind of, you know, drifted all over the place. I think ICANN does a lot of different things, and rather than focus on one specific thing, I just wanted to give you a general flavor of what we do. Fundamentally, we assign protocol identifiers. Most of them are really not controversial, you know, port numbers and what have you. And then some of them are very controversial, like .XXX. And one of the fascinating things about working at ICANN is that, you know, we get to deal with all those different things. And at the same time, you know, at some level, we're responsible for ensuring the internet interoperates. The fact that you can go to a web browser, type in sonoma.edu, and you can be sure that Sonoma State's website pops up is sort of, you know, really why we do what we do. So I hope that's insightful and gives you a sense of what we do, and very happy to answer any questions.
Oh yeah. Does the U.S. government have any control over you? Because there were in those articles like, "Oh, no, you can't," or whatever. That headline.
Yes and no. Yes, in the fact that the formal IANA function that we do is actually executed as a contract with the U.S. government, and this dates back several decades.
Okay.
You know, the internet was a U.S. government research project, and you know, it's a legacy of that. But on the other hand, we have a written commitment from the U.S. government that we're free to make decisions that we think are appropriate. So the U.S. government actually disagreed with .XXX, but we approved it anyway.
Okay.
So we do have some liberty to not do what the U.S. government says.
Okay.
Yeah, so you're talking about the like adding a whole bunch of new domains and opening it up so people can register their own domain. So were you guys planning to put some sort of prevention in there to prevent phishing and stuff like that?
Well, the controls for dispute resolution, I believe, is stronger, being proposed to be stronger in these new top-level domains. I mean, right now, there's already those controls for .com, .net. If you're a company and you see a domain that's very similar to yours, we have this process called UDRP where you can basically file a complaint against the registrar and have the domain taken off them. And that's been relatively effective. But, you know, because there's a lot of these new domains, those controls are proposed to be a bit even stronger than that.
With IPv6 having about 3,000 addresses per square meter of the earth, do you see IPv6 addresses becoming world social security numbers? And that way that, you know, you'll be assigned a few at birth and then it'll be recycled at death?
Well, actually, the way they're allocated is they actually hand out, I think, /48s, which what that means is that if you get an allocation from a RAR, you get 2 to the power of 80 addresses in your allocation. And the reason they do that is the whole last 64 bits can be used as your MAC address. And for those that are not aware, each network connector on a network has its own unique serial number. And right now, with v4, if you want to connect to a network, you have to use a protocol called DHCP, which then hands you an IP address to ensure that it's unique. If you use your MAC address as the last 64 bits of the address, it actually allows you to do automatic network connections without DHCP, because you know that part will be unique, and then the first part is the network that you're on. So the idea was not to hand out little chunks of it, but actually hand out very big chunks, which allow you to do a lot of novel things you couldn't do in a 32-bit address space. Yes?
Am I correct that you said you were called before Congress to address corporate interests?
Well, we were brought forward to talk about the new GTLD program, and the topic was intellectual property protection. So the topic on that particular presentation was intellectual property interests and what's the impact on intellectual property. We have testified before in Congress more generally about the program. It wouldn't surprise me if we're asked to testify again about some other aspect of it.
Other questions? Actually, Jacob's question was interesting. You are born and you're handed down an IP address, right? Eventually we'll have individual.
Because the port addressing scheme is going to be run up really quick, and I'm assuming that you'd have a self-representing scheme for service. Instead of HTTP, they did it, most programs communicate through that because it's easy to get through.
So a couple of things. One is that I don't think that because there's so many IP addresses that everyone will get their own personal allocation, simply because one of the things that doesn't scale is the global routing table. So there's a list maintained by every ISP that says this IP address belongs to this ISP, and that's how it decides to route traffic. So if one connection's with Comcast, the other one's with AT&T, it knows which blocks belong to AT&T and which blocks belong to Comcast. That list is so granular that it has a block for every person, and you have to have a huge list to look up for every packet that goes through a router. That's simply not scalable. So I think you'll still see the model where there's massive allocations to an ISP, and then that ISP will give you a sub-allocation as part of your internet access package and so forth. With respect to port numbers, you're kind of right that they're kind of running out, but port numbers are only used for each unique protocol. So long as people don't keep inventing new technologies, we should be okay. But people will keep inventing new technologies. So there are abstractions where there's records in the DNS, SRV records, NAPTA records. What they do is they basically provide port agnostic pointers to services on hosts. So it's hoped that in future protocol inventors will stop relying on port numbers and start relying on things like the DNS. And DNS will tell you what port number to point to, and then port numbers can be dynamic. Like I could run my website on port 1000, and through the DNS, instead of the DNS returning just the IP address, the DNS return the IP address and the port number, and know to connect there. So there'll be some scalability there as well.
Other questions? If not, well, thank you very much.